Hello everyone, welcome to Learn Data Structures and Algorithm in Python course. In today's lecture, we'll be solving another Leetcode problem on greedy. So let's see what is the problem. So let's say you are given some spherical balloons tapped on a flat wall, okay, and this is basically in XY plane, okay. So you'll be basically given a 2D array, and in that array, each point I represents two horizontal coordinates, start point, end point. So what is the problem? Like you will be given some points of balloons. So there will be some balloons, and in that balloon, there are only horizontal coordinates are given. And in this coordinate, this will be the starting point of the balloon and this will be the ending point. So for the second balloon also, this is start point, this is end point, this is start point, this is end point, okay, that are aligned, okay. So you don't have to worry about the y coordinate. We will be discussing only about x coordinate, okay. So here you can see this has some x coordinate and y coordinate. Now there will be an arrow, and you have to burst the balloons. So you can only burst the balloons if the arrow falls in this coordinate. So if this ax lies in start point and between end point, then only you can burst the balloon, right? How we can burst the balloon, that is the thing, okay. Now we have to tell how many minimum number of arrows is required to burst all the balloons. That is the problem, right? So let's understand through visualization. So let's take the first example, 10 16 2 8 1 6 7 12, right? So 10 16 2 8 1 6 7 12. Now let's assume, so what are these? This is basically for the first balloon, this is the starting point, this is the ending point, okay. So if you draw them, so for the first balloon you can see this is the starting point 10 and this is the ending point, right? So this is the first balloon. Then the second balloon, starting point is 2 and ending point is 8, right? For the third balloon, 1 6, right? 1 6. Then the fourth balloon is 7 12, okay. Like that balloons are aligned, okay. Now let's say you have given some arrows and you have to burst the balloon, okay. You have to burst the balloons. So you have to tell how many minimum number of arrows are required to burst all the balloons. So let's say I first throw one arrow in this position, okay, between 1 and 2, okay. Then this balloon will be burst, okay. Then let's say I throw one arrow at this between this coordinate, okay, 6 to 7, then I can blast this arrow. So there are basically two arrows. Then if I apply one arrow here, throw one arrow here, then this balloon will be burst. Then if I throw one balloon here, so for that case we require four arrows, right? To burst all the balloons we require four arrows. Now can we minimize the arrow? Let's see how we can do. Can we minimize this? So in spite of throwing like this, let's say I throw first arrow at this point, not this point actually. Let's say I throw one arrow between this point 2 to 6. Then what will happen? In a single arrow, I can burst two balloons at once, right? Then let's say I pick one arrow at this point. Okay. Then what will happen? These two balloons will be burst. So for that case, how many arrows are required? Two, right? So you can see, you'll be seeing this is our answer. This is the minimum arrow we are required. So now let's say how we can solve this problem. I hope you have understood this. What is the problem basically tell. So how to approach this? First approach is greedy, right? So in greedy, what we will be doing? So in greedy, most of the cases we'll be sorting the array, right? We'll be sorting the array. So here what we'll do, we can sort them based on starting point, or based on ending point. So let's say this time we are sorting them using ending point, right? Based on the ending point, and we'll sort them in ascending order. So first, what is the minimum? 1 6, right? So let's take this one, 1 and 6 first. Then the second thing will be 2 and 8, okay. 2 and 8. Then third will be 7 and 12, okay. And what will be the fourth will be 10 and 16, okay. This is done. Okay, then what we'll do, we'll take a variable. Let's say we'll take a variable as count. Okay, and we assume that at least we need one arrow to burst the balloon. We consider for to burst first balloon we at least require one arrow. Okay, that is done. Okay, then what we will do, we will consider this thing, the ending point of the previous bursted balloon, as end. Okay, as end. And our current iteration will be here. Okay, we'll be starting from index 1. Then what we'll do, we will check, is the starting point of this balloon is less than this end point. That means we will be checking, is this 2 is less than this ending point. That means this balloon is overlapping with the first balloon or not. That will be checking, right? If that is the case, then we don't have to increment the count, right? So we can burst the same balloon with the same arrow, right? We don't have to take another arrow, we don't have to spend another arrow. So let's write the condition. If if the starting of current, so let's write at start. So if this start is less than or equals to end. Okay, so start of current and end of previous. Okay, let's write like that. If the starting of current is less than equals to end, that means the same arrow can do the job, right? So what we have to do, we have to continue, means we'll not doing anything. Okay, we'll not do anything and we'll go back to the next iteration. Okay, so then what we'll do, so same balloon, same arrow can do the job. Okay, then what we'll do, again we'll be going to the next element. Okay, so here also what we'll be checking, same thing we'll be checking, is less than ending point. So here it is 7, starting point is 7, ending point is 6. That means they are not overlapped. So here you can see, this is the ending point of first balloon, this is the starting point of the next balloon, so they are not overlapped. That means so let's write it else condition. That means we need one more arrow for that, right? So what we're gonna do, we'll be incrementing this count by 1. Okay, incrementing this count by 1. And what we'll do, change our endpoint from here to here. This will be our new end. So end will be so current, so let's say error of current will be I. Okay, then the index 1, that will be our end, we'll be updating our end. Okay, that is done. And we'll be incrementing our count. So count will be 2, number of arrows will be 2. Now what we'll do, now again we'll move to the next element. Okay, so this is our end. So is this start is less than end? Yes, right, the start is less than end. So we'll be continue and we'll be going to this index, and this is out of bound, so we'll be returning from that. And whatever the count we are getting, that will be our answer, right? This is pretty simple, this is pretty easy. So let's write the code for this. So first thing, we'll be sorting the arrays based on the index 1, right? End element, actually end coordination. So let's sort them first. So points dot sort, then the key will be sorting this in ascending order, so then don't have to put any reverse equals true or something like that. So now let's put the key. So key will be, sorry, a lambda function, and here we'll be sorting based on the index number 1, right? So next, int coordinate. Okay, then that is done, so we have sorted. Then what we'll do, we'll take a count variable. Count initially it will be 1, then take a pointer I equals to, initially we'll be starting from index 1, right? So okay, then what we will do, we'll take a end. Okay, end will be, so let's take first balloon. Okay, points of 0 of 1, right? That will be our first end. Then write a while loop. While this I is less than length of this points, okay, length of this point, then what we'll do, we'll check if what we'll check, if the start point, so what will be the start will be points I and 0, right? If the start point is less than or equals to end, okay, then what we'll do, we'll continue, right? Okay, so before continue, what we'll do, we'll be incrementing the I, so I plus equals to 1, done. Then we'll be continuing. Else what we'll do, else what we'll do else what we'll do, that means they are not overlapped, right? So we'll be incrementing the count, so count plus equals to 1. Then what we'll do, we'll change our end will become, so points of I and 1, right? Points of I and 1, and again we'll be increment our pointer. Okay, okay, then at last we'll be returning this count, and that will be our answer. So let's run this code and let's see. Okay, for the test case it is working. Let's submit this. Yeah, so you can see this is accepted. So I hope you have understood the problem.